So our first case will be log equals log. And our second case is going to be log equals number. Okay, so we're going to go through case A first. And it tells us, the rule tells us, if I have log base b of x equals log base b of y, then we can conclude that x has to equal y. And this is sort of intuitive, right? If I have a log with the same base on the left side equals the log with the same base on the right side, wouldn't their arguments then have to be equal to each other also? So let's do a problem. If I have log base 5 of 2x plus log base 5 of x minus 4 equals log base 5 of 48 minus log base 5 of 2. So what do you think I'm going to tell you we should do on both the left side and the right side? You got it. We're going to condense it down to 1 log on the left side. We're going to condense it down to 1 log on the right side. So on the left side, I'm going to have log base 5. Since it's log addition, I'm now going to multiply them, of 2x times the quantity of x minus 4 equals log base 5 of 48 divided by 2. So now that I've got it down to 1 log on the left side and 1 log on the right side, and I want to make sure they have the same base. Do they have the same base? Yes. So now that it's 1 log equals 1 log, now all I have to do is set their arguments equal to each other. So I'm going to have 2x times the quantity of x minus 4 equals 48 divided by 2, which is 24. Any guesses on what you think I'm going to have to do here? What's your name? Sean? Yep, we're going to start off by distributing the 2x. So we have 2x squared minus 8x equals 24. Looks like we're going to have to factor, right? So I'm going to move that 24 over. Minus 8x minus 24 equals 0. Now, when we factor, the first thing we should always look for is what? Yep, GCF. Let's pull out that GCF of 2. So we have x squared minus 4x minus 12. And we can absolutely factor this. If we couldn't factor it, what would we have to use? The quadratic formula, yeah? So we're going to have x minus 6, x plus 2. 2 can never equal 0, so that's out. And we're going to get x equals 6 and x equals negative 2. But we're not done. So if you guys remember when you first started talking about the log equations, you had y equals to b to the x, right? That was an exponential, and we could change that exponential into a log if we wanted to. And what was super special about the exponential is that it was, generally speaking, that our exponent was the unidentified variable, right? So it would look something like y in an exponential equation, y equals 2 to the x, right? Right. And when you talked about this, there were certain criteria that had to be met. What was the criteria that had to be met? We had to know that b could never, or b had to be greater than what number? Our base had to be greater than zero, exactly. And so because my base has to be greater than zero, when we now turn this into a log, can my argument or what this equals, so if I have 2 to the x power, no matter what number x is, can it ever be negative? It can never be negative because you have a positive number, and no matter what exponent you raise that positive number to, it's always going to be positive, right? So when we enter into the world of logs, there's two things that need to be met. We are going to have in logs, the base is positive. Therefore, these three little dots means therefore, the argument must also be positive. Because remember, when you have a log, the argument is the answer after you raise some base to that exponent, right? The argument is the answer to that. So if my base is positive, no matter what exponent I'm raising it to, it will always be positive. So now that we know that the argument must always be positive, guess what I have to check for here? Check for extraneous solutions. And when we check for extraneous solutions here, we actually don't need to simplify the logs to make sure the left side equals the right side. All we have to make sure of is that I don't get a negative argument. And what we have to go back to is our absolute first problem before we manipulated anything. So before the manipulation, we go back to the original problem. And I have x equals -2. If I have x equals -2, and I plug -2 into this very first log, 2 times -2 is -4. Can an argument be -4? No, this is saying 5 raised to some power is going to give me -4. Is that possible? Never. So guess what we have to do with that -2? Reject it. Do I still need to check the 6? Yeah. So now we look. Well, 2 times 6 is 12. Are we okay with a 12? Yeah. 6 minus 4, +2, still okay? Anything to check there? No. So is 6 an acceptable solution? Absolutely. So our only solution here is x equals 6. Okay, you guys try this one. Mm-hmm. Oh, yes. The answers are, if you scroll down, should be at the end of the worksheet, all the answers. Is it not there? The original worksheet. Okay, well, we're in lesson right now. We're going to go over the homework after. Okay, guys, let's go over this. So here, well, you tell me, what'd you guys get for X? 6 and -4. Hold on, I'm looking at the wrong one. Sorry. I'm like, where'd we get that? Yes, 6 and -4. Did you keep both solutions? Yeah. Why?
Plug in the 6 works. When you plug in the -4, it'll be x squared.
Ooh, but remember, where do we plug it into? The original, right? You always have to plug into the original, and the original is not x squared in the parentheses. The original is 2 times log base 3 of x. So this is saying 2 times log base 3 of -4. Can 3 to some power ever equal -4? No. So we reject it based on that immediately. Yes. But that's not what it is, because no matter what, that x can never be negative. It can never be negative because even when this is, if this were x squared, log base 3 of x squared, this is the same as saying log base 3 of x times x, right? X squared is log base 3 of x times x, which is the same as log base 3 of x plus log base 3 of x. So no matter what, that argument can never be negative. And keep in mind that 2's in the front. Right? So we never want that argument to be negative, even if it's getting squared. So with that said, can we keep that -4? No. Does anybody need to see how we got the 6? All right, next one. So now we're going to talk about case B, where it's log equals number. And when we have log equals number, what we want to do is make log side into a single log. Then change to exponential, then solve. Okay, so what do I mean? Let's do an example. If I have log base 4 of x minus 1 plus log base 4 of x equals 1. So now I'm going to condense the left side down to 1 log. How am I going to condense this down to 1 log? We're going to have log base 4 of x times the quantity of x minus 1 equals 1. Now, biggest mistake I see is now they try to take x times the quantity of x minus 1. Guys, stop touching each other. X times the quantity of x minus 1 equals 1. How come I'm not allowed to do that? How come I'm not allowed to say x squared minus x equals 1? What's your name? Isabella. Isabella? Isabella. Even if there was a different base, what does it matter?
It's all.
You got it. Exactly. Because there's a log on this side. Is there a log on the other side? No, not only would there need to be another log on the other side, but there needs to be a log that's even a base of 4. That would need to be the same base. So not only is there not even a log with the same base on the other side, there's no log on the other side at all. So I can't just say my argument equals 1. Can't do that. So new course of action here. It's not log equals log anymore. It's log equals number. Well, can I change every log into an exponential? And can I change every exponential into a log? So that's what we're going to do. We're going to change this into an exponential. So remember, when we have a log, it's log base, our argument is our answer, and it equals our exponent. So when I go to change this into an exponential, it's going to be 4 raised to what power? To the first power, yep, 4 raised to the first power equals my argument, which, are you guys okay if I write x squared minus x? I just distributed in that x. Now I can look at this and say, oh, I think I need to factor, so I have to subtract that 4 over. But then I realize, can I factor this? No, there's no factors of 4 that will ever add to 1. Never going to happen. So what do I have to use since I can't factor it? The quadratic formula. So we're going to have x is equal to negative b, which is a positive 1, plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times c, which is negative 4, all over 2 times 1. And so we're going to get x is equal to 1 plus or minus the square root of 17 all over 2. Do I still need to check for extraneous solutions? Absolutely. Now, I don't know, 17 is not a perfect square, right? So we have to estimate this. But do we agree that the square root of 16 is 4? So the square root of 17 is going to be bigger than 4? Maybe like a 4.1 or a 4.2, something like that. All right, so we're estimating. For the sake of just figuring things out, I'm going to just use 4 as the root of 17 because we know it's approximately 4, a little bit bigger. So if I have x equals 1 minus 4 over 2, is this going to be a positive or negative number? This is negative. So now when I have this negative number, it's around negative 3.5. 3 halves, which is about negative 1.5, right? About negative 1.5. So when I go to plug into the original problem, if I had negative 1.5 minus 1, isn't that still a negative number? So can I have the negative version of this radical? No, I'm going to reject this negative version. I have to check the positive version. So the positive version is going to be x equals 1 plus 4 over 2, which is about, right? About 5 halves, which is about 2.5. So I go back and I look. 2.5 minus 1, are we still good? Yes. 2.5 is good. So now our x is only the positive version, which is going to be 1 plus the square root of 17 all over 2. So in my last class, they asked, okay, well, do we always just reject the negative number? No, you can't just reject the negative number because let's say, don't write this down, but let's say I had the log of base 4, 5 minus x, okay? And I have that x equals negative 2. Well, in this scenario, if x equals negative 2, wouldn't that make the argument positive? So would we be okay? Yeah. And if I had x equals 10, well, wouldn't that positive x make my argument negative? So you always want to check. That's why I'm showing you all this. You always want to check. You can't just assume because it's negative, it's going to be rejected. All right, next problem. You guys try this one on your own. Was that your notebook for the whole year? That is so little. My class would have finished that in like half a semester.
Well, this is big and I write small. So.
That's big?
Yeah.
Is that college ruled?
Yeah.
Okay.
I finished the entire binder.
You write really big. That's
Well, that's true.
I write small. I literally write small and anything. Write smaller than you're not.
Really small.
Write smaller than
I just write really, really small.
Look at her notebook. It's not even called.
That's crazy. And she's like spaces out.
Because like some of my pages look like this.
And you leave.
Oh, wow. All right. Do we have an answer? Do we have an answer? Yes, no, maybe so. What'd we get for Y? I heard 4 and I heard 8. Is that what I heard? All right. The 8 is wrong. The 4 is right. I guess we need to do this. Yes. Okay. So we're condensing the log side. So we have log base 2 of Y times the quantity of Y plus 4 equals 5. So we have log base 2 of Y squared plus 4Y equals 5. Can I just say Y squared plus 4Y equals 5 and solve for Y? No, it's not log equals log. Log equals number. I can't set the argument equal to 5 because there's no log on the other side. So what do I have to change this into? Exponential. 2 to the 5th power equals Y squared plus 4Y. Well, 2 to the 5th power is 32. So I'm going to have Y squared plus 4Y minus 32 equals 0. So we're going to get a Y plus 8, a Y minus 4, and then when we solve, we're going to get Y equals negative 8 and Y equals positive 4. We reject the negative 8 because if I go back to the original problem, it would give me a negative argument. So for that reason, we reject the negative 8. The 4 works out perfectly. All right, 2 more problems, and then we could go over the homework.
Really? I didn't like. I didn't like confused. I didn't like the book. So, like usually I do the math. I was too lazy to write. I was too lazy to switch back and forth, so I just did all that stuff.
Okay, so this looks a little bit different. But it does still look like log equals number, right? Okay. And normally I say, well, condense it down to 1 log, right? Condense it down to 1 log, then make it exponential. But can I condense this down to 1 log? No, there's nothing. There's no plus signs there. There's nothing to sort of like put together. So what I'm going to do, this is my, most people like to say, well, normally when you see parentheses, you're like, okay, we have to work from the inside the parentheses out. That won't work this time. So what I'm doing is I'm actually looking at the outside log base 3. So I have log, my base of 3. This whole thing is my argument. And placing that whole parenthesis, that whole expression as my argument, I'm now going to turn this into exponential. When I turn this into exponential, it's going to be 3 to what power? The 0 power equals the whole entire argument, which is log base 3 of log base 3 of x. And anything raised to the 0 power is 1. So now I have log base 3 of log base 3 of x equals 1. Well, guess what I'm going to do again? Same thing, but this time this is my argument. So now when I change this log back into an exponential, it's going to be 3 to what power? The first power equals the argument, which is log base 3 of x. Guess what? Doing it one more time. So when I have this, it's going to be 3 to what power? the third power equals what? X. Now, the rule in my class, if the exponent is 5 or smaller, you have to multiply it out. If it's bigger than 5, you're allowed to leave it as an exponential form. So because 3 to the third power, that exponent is lower, we have to multiply that out. So we know 3 to the third power is 27. All right, last problem for today. What number is this for?
So if it's bigger than 5, we down 1.
Correct. So this is a very sneaky problem because you have a log on the left side and you have a log on the right side. So your instincts are like, okay, great, easy peasy, log equals log, let's set their arguments equal. What is stopping us here? What is the hesitation, Caroline? The -1, perfect. That -1 is not part of the argument. Can I just put it as part of the argument and do x plus 8 minus 1 and just get x plus 7? No, remember I told you back from the do now, right? If it's not in the argument, I can't combine it with the argument. We can't combine it. So this doesn't work. I can't just say x plus 8 minus 1 equals x. Can't do that. So what we're going to do is we're going to change this into a log equals number type of problem. How am I going to change this into a log equals number? Well, I'm going to go ahead. I'm going to add that 1 over. And I'm going to subtract the log base 5 of x. So I'll have log base 5 of x plus 8 minus log base 5 of x equals 1. Everybody okay with what I did? Okay, so now it's not a log equals log scenario, it's a log equals number. So what do we have to do on that left side? Condense it down to 1 log. So we're going to say log base 5 of x squared plus 8x. Everybody okay that I just distributed in that x? Okay, equals, oh, sorry, that was wrong. It's subtraction, so the subtraction should be division. Sorry, who caught that? I heard a couple weights. Somebody had caught it. Good job. All right, so that's going to be x plus 8 over x equals 1. Now what do I do? Turn it into an exponential. So we're going to have 5 to what power? The first power equals x plus 8 over x. So now I have 5 over 1 equals x plus 8 over x. I'm going to cross multiply. So I get 5x equals x plus 8. Go ahead and solve. We're going to have 4x equals 8. So x will equal, no, 2. Yes, not a half. X is going to equal 2. Do I still have to check it? Yes, we still have to check the answer. So where do I go back to check this? The original. So if x is 2, 2 plus 8 is 10, we're good. 2 is still good. So we are set here. That's our final answer. All right, so we are done with